Hey everybody, this is video 2 in the series of creating, comparing, and simplifying algebraic expressions. So in the first video, we sort of established a definition for what x squared means in terms of a visual. So we have the x squared tile, and then also what an x term would mean, and we've got a visual for that as an x tile. So what I want us to do is to take a little time out to actually build some visuals. And yes, I actually mean to build, okay? So your covering teacher, whomever is in with you today, has access to what we call algebra tiles. And you may have used these in the past. If you haven't, not a problem, okay? They're pretty handy to use. And of course, it's all about visualization of these algebraic terms. And we're going to use them to perform operations as well. And the visuals will help justify a lot of the moves that we end up making when we start writing about operations with algebra. Okay, so we're going to pause the video here. You're going to get your supplies all set to go, and we'll go from there. So now that you've got your supplies available to you, what I would ask you to do, and it might seem kind of strange, but there is a point to it and all. I'd like for you just to take some time to build, something. It can be very simple, it could be kind of complex, but I'd like for you to use these tiles, these algebra tiles or area tiles, to build a particular visual. Okay, so again, we'll pause and take time just to build something for yourself. So now that you've got something built, okay, where does the algebra come in? Okay, so what I want you to know is that those colored tiles that you had, so each one takes on a particular value. So notice that in the very first video of our series, that this tile here, we were already using this one, okay? So we refer to that as the positive x squared tile, okay? And much like any integer, if you have a positive number, it has what we call an additive inverse. So its inverse or its opposite would be negative x squared, okay? Now, the reason why we have these two types of tiles, and I'm just going to move these off to the side for a second here, is I want you to realize that they are together a zero pair, because they are the same area, except they're opposites, because one is designated as a negative, the other as a positive. So what that means is that they will add to zero. And we often use the term cancel, but really what we mean is that they're zeroing out. So when we build our diagrams and do calculations, this will end up being a zero and won't impact our final answer. Okay? Same thing happens over here. So we have a positive x tile and a negative x tile. So together, they too form a zero pair. Okay? So there's another zero pair. And the same thing happens here with the unit tiles. Okay? So 1 plus negative 1 giving us 0. And we can actually write that out. We could write that numerical statement, much like you've done in the past. Same thing up here. X plus its opposite would be 0. Or 0 x's, I guess, which is equal to 0. And same thing up here. I could have x squared plus negative x squared. That would give me 0x squareds, none left, just a 0. I guess I could have put that in here too, as a 0x. And I guess just to be more formal, following my conventions from top to bottom, best way to do it. There we go. Okay, So those are our definitions. So what I would like for you to do now is to go back to your diagram, okay? And I want you to think about what the total area of that diagram would be. So remember how these zero pairs form. Think about, how that's going to play out in your own work, and then we'll pick it up in just a few moments. Okay, so let's pause the video and give yourself a chance to sort of think about that. Okay, well, now that you have, what I'm going to do is I'm going to show you with my own diagram the sum, okay, otherwise meaning to add. So I'd like to add the areas of these tiles in my diagram, okay? So I'm just going to move things around a bit, give myself a little space to work, and I'm going to dismantle my diagram. Okay. So what I'm going to do, I'm just going to take looks like the tail, I guess, of this animal. I'm going to take this negative x off, and I'm going to pair that with a positive x tile. Okay. So realize that these two are zero pairs. So I'm just going to put, just going to categorize this. Call it like the trash bin, or maybe the zero bin, I guess. I'm just going to put these over here. So there's a zero pair. Okay. Now what else do we have? We have no other negative x tiles, so these sort of can kind of be on their own. So let's move these together like that, and I'll let those be. Now the negative x squared does have an inverse, that is an additive inverse. Its opposite is right here. So there's a zero pair. So let's bring that over here. Okay, put that in the trash. There are no other positive x squared tiles, so that stays. And yeah, you've guessed it, the 1 and the negative 1. There's another zero pair, so we'll get rid of that. And we're left with a negative 1, or a negative unit tile. So I now have all of these tiles. Okay. So this would be the area. Okay. So in terms of a diagram, here's what I have. So the area of my diagram is equal to negative x squared. Just going to move these together a little bit, give myself some space, plus 3x tiles, plus a negative unit tile. Now, if you want to just represent them in terms of symbols and not necessarily the tiles, that's really our next step. So we have a negative x squared tile, and there's one of those. Then we have 3 of the x tiles, and then one of these negative unit tiles. And if you'd like to sort of drop the parentheses on that negative 1, adding negative 1 is the same as subtracting 1. So this becomes the area expression right here in terms of symbols for the diagram that I had created, which is here. Okay. So the area expression is negative x squared plus 3x minus 1. So I would really encourage you to pause the video and go back to your own diagram and then do that type of work. So look for the zero pairs, start moving things around, find those zeros, and then look at what you have left over, and then organize it in terms of squared tiles first, x tiles next, and then your unit tiles as the last term. Combine them, and then you've got yourself an expression for area. Okay, so I think that's it for this video. I'm just going to check my slides and make sure that, yep, we're in good position.